our next guest ready now. Joni Klippert is the founder and CEO of StackHawk, following on from external threats in lock files and package managers. So StackHawk is an application security SaaS startup built to help developers find and fix security vulnerabilities in their code. So thank you, Joni. The floor is yours.
Oh, thank you so much for having me. Happy to be here today. Let me grab my notes. Awesome. Thank you so much. As was introduced, my name is Joni Klippert. I am the CEO and founder of StackHawk. I have been building software for software developers since I graduated from my MBA program in 2010. And in 2019, I founded StackHawk to bring application security to the DevOps workflow by helping software developers find and fix security bugs in their code before they deploy to prod. My co-founders and I saw an incredible opportunity to reimagine application security through a software engineering lens. So in this talk, I'm going to share what key DevOps tenets have been sort of missing so far in the realm of application security that have somewhat hindered AppSec from shifting left into the developer workflow, and what we need to do to modernize the practice and rapidly deliver more secure software. So DevOps is pervasive and it works. And what I mean by this is that DevOps has unlocked the ability for companies to deliver value to their customers faster. So over time, we've seen pretty major shifts in tooling and processes that help us do just that, and that is develop software quicker, get features into the hands of our customers faster. So Agile, unlock the ability to quickly plan, develop and deliver software more rapidly. Virtualization, cloud, and infrastructure as code removed that sysadmin bottleneck as we really empowered engineers to deploy and manage their resources. And then we saw massive efficiencies with automation throughout the integration and deployment pipeline, and then further unlocked speed with orienting to very small releases, breaking up the monolith, and investing in microservices architecture and containerization. And then we really improved our uptime by creating the ability for software engineers who wrote the code to then manage that code in production. So the next sort of most important area of investment is to empower our engineering teams when it comes to AppSec. And when we do this, we unlock the ability to not only deliver software quickly, but more secure software quickly. So whether you're part of a younger company born with the technical and cultural tenets of DevOps, or part of a legacy enterprise that's undergoing digital transformation, we invest in these principles to quickly respond to customer needs, deliver high quality software, and ultimately remain competitive as a business. So why hasn't AppSec followed the rest of sort of the product and engineering organization in shifting left? As I was doing research for StackHawk, I wanted to understand why security hadn't yet made it into the developer workflow. I interviewed more than 50 CISOs and security professionals, CTOs, VPEs across the entire stack. And in a matter of weeks, I found that we both had some cultural barriers and some technical barriers to current solutions, as well as some pretty, as I mentioned, meaningful cultural barriers. So the most glaring thing that stood out to me was that the relationship between security and engineering was pretty deeply strained. It wasn't too dissimilar from early days of sort of your traditional IT ops versus dev, and it was maybe a little worse, honestly. These teams have very different KPIs and operational objectives. So whereas your engineering teams and development teams care about focusing on business objectives, security teams are aligned to reducing risk, oftentimes in a way that can come across to the engineering team as at the expense of the business objective. And it fosters some kind of interesting cultural issues. So you'd hear a lot of kind of lack of trust and empathy, things like you'd talk to security folks about engineering being more involved in AppSec, and I'd hear, oh, you can't get software engineers to care about security, to which I totally call BS. From engineering, I'd hear things like the security department being the department of no, or difficult to work with. The next is a really important tenet of DevOps, which is transparency and observability. And that was something that was missing in the security discipline today and a lot of the tooling decisions that are made. So developers commonly don't operate in security software. This is changing, which is good. There's a little trust that developers should be able to see or action on issues unless a security person tells them to, which is really inefficient since the engineer is responsible for fixing the issue anyway. And then lastly is a topic of empowerment. So my co-founder, Scott Gerlach, was formerly the CISO of SendGrid, and he would talk about how we want developers to care about security, but we don't always trust them to take a first pass at assessment and resolution of issues. So he comments on this tendency for security teams to buy AppSec software and then lock it down so tight with approval gates everywhere, it's impossible for software engineers to use. And then if you set aside the cultural things, there are a lot of technical challenges that I think companies face when trying to modernize AppSec. First thing is most tools in the market were built to run against production by the security team. And there are several issues with the production bias, and I'm going to double click on this in just a minute here. Second, a lot of the tooling is really hard to configure and deploy. Many, especially in the land of DAST, which is where StackHawk operates, which is testing the running application, it can be difficult to get those capabilities working in a repeatable manner, and making automation really difficult because a lot of the tools just weren't built for it. And most AppSec tools were built with the idea that a human would manually run tests against an application. And again, this is starting to change, which is really good. Third, a lot of these tools generate a lot of noise. So the output is super verbose and it's written in a very security person language versus something that's really easy for a software engineer to quickly grok it and action on it. And we all know that a key component to DevOps tooling is to really mitigate noise and ensure that a software engineer's attention is really only drawn to what is important so that they can keep moving on and delivering business value. And lastly, there's a lot of conflict with some of how these tools were built, and those tools running in a more modern developer tooling and processes system. So on the previous slide, we talked about security folks saying, okay, devs don't care about security, but with this list of challenges, it's like, how can they afford to care about it? It's really expensive to care. So we're going to talk about some ways that we can change this. So in a world where software engineers are largely measured by delivering business value, the cost of caring can be too high. And then we're going to talk about how to lower that cost of care. So we discussed that a lot of AppSec tools in the market are built to run against code that's already been deployed to prod, and they're designed to be operated by a security professional. This orientation toward production and lack of involvement by the development team at the right time with the right context makes it impossible to modernize AppSec. Please excuse me. So AppSec tools, as we just talked about, are commonly run in prod by either the security team, because prod is where they know the app the best, or by a pen tester, because that's their point of access. In this context, it makes sense that these tools to date have been designed for these groups. However, it's highly inefficient. Both groups struggle to instrument their tests because they're less familiar with how the application works. So setting up an engagement can be a pretty heavy lift to get a really good assessment. From there, the primary value, because that lift was so heavy just to get the technology running, these teams can really value the finding of things. So the number of things found versus finding and fixing the right things are the most important things. So the things we don't want to focus on is just the number of issues that are found. And this can be really inefficient because the finders aren't the fixers. It happens way too late in the process. And when a team breaks someone's stuff, oh, look, I found all these security bugs 6 months after you deployed this to production, it kind of fosters that adversarial relationship. So I'm not advocating that people shouldn't get pen tests or that the security team shouldn't even be involved. That's not what I'm advocating for. I'm just suggesting that the production environment is not the first place that we should be finding out about this kind of information for our applications. The next most critical part of the production bias is timing. So as companies are rapidly, more and more frequently, like many times a day, shipping code to prod, if security is not baked into this workflow, what we find is either you're not rapidly shipping code, in which case AppSec processes act as a barrier to shipping code, or the security team is constantly playing catch up. And that's what we actually find is to be the most common thing, is that folks don't really feel like they have control or knowledge of the security of the code that they've put into production. So it gets worse. This always kind of makes me giggle, but it shouldn't. When AppSec tools favor running in production, like obviously the bugs are already in prod. So there will be a lot of times where we intentionally ship bugs to production, but the intentionality is the important thing here. So it should be done with eyes wide open, and it should be a risk-based decision. So you might know that exposure is super limited and that issue will be fixed in the next sprint. That's great. But production is not the place that you should be finding if there are any security bugs. The next part of the production bias is context. So a check for security bugs in prod, like X period of time after it's been released, is inefficient. So engineers have moved on to other sprint tasks. They're no longer in the context of their code, and fixing involves context switching, which can be very expensive. So when scanning for bugs in production, typically tools are scanning an FQDN like www or app. And the result can be, especially with DAST, a really long list of bugs that exist somewhere in the application. And that makes it really difficult to identify the app or the service that's affected. And it lacks the context of the specific data that's handled by that service. So you end up with a lot of like ticket shuffling, trying to identify the service that was affected, trying to identify the team who owns that service, and then trying to work those issues into the sprint. So when we talked about an inherent focus on the number of bugs found, and then the percentage fixed over time as being a primary driver of value, it also totally ignores the business context of the findings and trade-off decisions around business value generation. So instead, we really need to be engaging in discussions like, how important is this application or service to the business? Should we be fixing all of the bugs on an internal application or just going fast on that? And how should we think about our apps and the data that they handle? So the production bias results in the wrong team. And what I mean by that is the team that isn't ultimately going to fix the bug, finding vulnerabilities at the wrong time because they're in production and without appropriate context of the app or the service that is how that runs, the data it handles, and what it means to the business. So this is how security-based development works and should work. And I'm just going to read the slide because it's poignant. So when a team writes code, they know that the syntax because it won't compile. When a team merges code, they know that there's a problem when it doesn't merge. When a development team runs unit tests, they know the code is wrong when it fails the unit test. And when a team runs integration tests, they know the code is wrong if it doesn't work as it's designed. And when a team introduces a vulnerability, they should know right away because it should fail a security test in pipeline, just like the rest of the checks and tests we put into our code base. So at this point, I super want to emphasize that instrumenting test-driven security is something that engineering teams can and should do. So even if they don't yet have a security team or function at their company, it's something that an engineering team can totally run with, just like they do the rest of their tests. So let's talk about getting it right. So what does the right team look like when it comes to AppSec? It's developers and informed stakeholders. Developers fix security issues, so let's make them aware of those issues as they're writing code. And in this world, we're reimagining the role of security as a coach whose responsibility is to enable the team to be successful. So there's a ton of value in optimizing for the developer experience, right? It's super efficient because engineers are able to find and fix issues in flight. It democratizes security information across the organization. Security becomes a standard discussion while we're building software. It affords collaboration among teams at the right level and provides an opportunity for targeted education. And then the security team is able to scale. We all know that we cannot scale our security practices with humans. We have to do it with automation, and we have to do it with our software engineering teams. So as a pro tip, it's like absolutely leverage pen testers for security reviews, tough business logic findings, but not as a primary point of access to your security posture. Now let's talk about the right time. So the right time to be checking for AppSec bugs is pre-production. We should be instrumenting our security tests in CI/CD to give engineers feedback immediately on the different services and applications that they're working on. So many of our customers are checking for AppSec bugs on every PR or merge. And this is ideal because if a security test fails, you know you introduced a security bug in your latest change. And then when we add the ability to test locally, engineers can really tighten and quickly iterate on that fixed test loop if a new bug is identified. So for AppSec to modernize, engineers need to be able to test while writing code and test while they're building code. And our security teams or tools need to play really well in these phases of development. So the next piece is getting the right context. So the right context for security bugs in your code is as you're writing it. And when this happens, engineers can fix really egregious security issues in flight. And that's going to result in less bugs making it to production and less rework later. Next is in context of the application itself. So the most important piece of context that comes through with real-time security testing is the context for the engineer of the application that they're working on. So teams can leverage their microservices architecture to instrument security checks on smaller bits of code, which make it easier to isolate and fix those security issues. So teams should also be able to make better judgment calls when they know the job of the app that they're testing and the kind of data that it handles. And then the third piece of context to get right is business context. So we have to empower software engineers to fix the most important things, not all the things, while they're in context of their code. And the security team really should be collaborating with engineering on assessing business risk and working across product and engineering to triage sort of those lesser severity issues based on resources, business objectives, and risk. So when the right people are doing the right jobs, there is a bridge built between security and development. The goal of the security team becomes enabling the business to go faster, safer, and they lay the right foundations to focus on scaling that security organization within their company by empowering software engineers and helping to serve as educators around risk. When this happens, the development org can build more secure software faster. We talked about that. And when we automate the job of finding AppSec bugs, we empower software engineers to fix those issues in flight, and security becomes a very natural part of the software development process. So that was all very theory and high level, and I wanted to show you a quick diagram of how a modern security workflow can work. So this is how leading teams can introduce instrument security and CI/CD. Next, we're going to talk about a bunch of different tooling to get started with. But as you are sort of checking in code, it compiles and builds. At that point, just in the same point that your unit tests are running, your integration tests are running, this is where your security tests should be running. And then building tools and pipelines that allow you to have some optionality here. One, you can run it async. Two, you can run it in pipeline, which means that if the security test passes, it gets packaged, it gets deployed, goes through its natural process. If a security test fails, you have the option to break a build, go through finding details, recreate the issue, and then further triage that by either fixing it, creating it, or creating a JIRA ticket, and then re-merging that code back into your pipeline. So that is how sort of a more modern way of doing application security testing works. So I know at DevSecCon there is a variety of backgrounds. So you might be thinking, okay, that's awesome. I don't know where to start. So if you're a software developer, I'd start thinking about security testing just like you would integration testing or unit testing, and as part of a required software delivery pipeline that the engineering org owns and instruments. From there, I've included a couple great types of AppSec tools that every company should be using. So we've got SCA, or software composition analysis, that really helps teams identify vulnerabilities in open source libraries or containers. These tools compare versions of libraries or third-party components that you're using to known vulns, and an alert, alerts users when it's time to update. Next is DAS, that's the world that we live in. So dynamic application security testing, which scans your running apps and APIs for vulnerabilities. It's an active scanner that can sort of simulate an attack on your app with inputs, seeking outputs that indicate a present vulnerability. So the nice thing about DAST is, since it reports successful attacks, there are less false positives. So to get started, if you're a software engineer, you can skip step 1 on this slide because you know your app, and simply choose an app or service and start scanning for AppSec bugs. Choose the technology and just start scanning in pipeline. And as you get comfortable, you can layer in additional applications and technologies that provide a more robust security posture. So that is it for me. Feel free to email me at joni@stackhawk.com or visit Stackhawk to learn more about how we're putting AppSec in the hands of software engineers. And I hope you enjoy the rest of the conference.
Thank you, Joni. We do have a couple of questions. The first is, so how can developers watching this talk convince their management of the importance of that baked-in security?
You know, that's a great question. I think as somebody who has managed software engineering teams in more of a product capacity before my CEO hat was put on, is the disruption and the cost of unplanned work is really, really hard on an organization, because we're making a lot of promises with roadmap to our customers and to our business constituents. And when you get a bunch of vulnerabilities dumped in your lap to disrupt a sprint, it is very expensive for engineers to context switch to fixing something, maybe code that they haven't seen or touched for 6 months. So that's a very meaningful cost to the business, because we're switching context and we're not working on business value anymore. And then 2, this is not the first thing that we lean on, but if you're waiting to assess risk until production, you're instrumenting risk into your business. And so I would encourage folks to not do that, especially if it can be automated as part of just actual traditional software delivery.
Great, thank you. And Catherine asks, do you have any recommendations for the catch-up portion? So the example that she gave was running an SCA tool that detected lots of vulnerabilities and generating so much feedback that the team then doesn't know how to prioritize which things they should fix.
Yeah, that's another great question. So, you know, we spend a lot of time in the realm of DAST, and as we onboard our customers, a very important place to start. So they'll start running security tests on a certain application. And we're like, you've got to baseline that app. So sit down with your team and make sure that you've triaged everything. It's like either, you know, fix the most egregious issues, make tickets if those are things that you want to fix with additional resources later. Or sometimes in tools, you'll find false positives or things you're going to risk accept. And it's really important to do that baselining because when you're running it in pipeline, if something net new pops up, it's like, I have to pay attention to this and I have to fix this issue. Another thing, not to be pitchy, but to help engineers focus on the right things, we just released an integration with Sneak Code, so the SAST product. So what's really great about that is SAST can find a whole lot of issues that may or may not be accessible to the internet. And DAST shows we were actually able to successfully attack this. It is accessible to the internet and it is vulnerable. And by correlating those findings, yes, it was accessible from the internet. Here's the line of code that you need to go fix. That helps a software engineer know exactly what to do while they're in context of their code and eliminates a lot of that noise. Our market and our tooling across all of them have a lot more work to do here to make sure that it is not a disruptive process for software engineers and to fix things. But I think the leading companies get it. We're aware of the problem and our best people are on it. And we're working on fixing that for software engineers.
I mean, I think that's the kind of next stage of this problem, really, isn't it? Is being able to actually say, I mean, obviously, I hold my hands up that I work for Sneak, so this is a familiar space for me. But you know, where you know, is that code path actually being executed, or you know, in the context of you know, of cloud deployments, can I actually get to that? You know, and it's being able to, and I think as an industry, we're all starting to get on that road, but it's taken a very long time to be able to have the data and the you know the frameworks to be able to make those connections, you know, to say, and you know, it's taken infrastructure as code and all the rest of it so that we can actually say this is how something is in reality in production right now before we can start making those kind of calls. We have one more question from Kevin, Joni, who says, how do I create a security awareness program for developers to ensure best practices in the SDLC and not engage in war with DevOps? I'm not sure who Kevin works for, but
well, listen, engineers really care about the quality of their code. There's a lot of pride associated with delivering great code to customers, and it includes security, right? I think to not engage in a war is to not let perfect be the enemy of good. Get tools that run in their processes, in their systems. You cannot take, so DAST, like a legacy problem with DAST, is it could take like days to run. You can't run that in pipeline. So you have to find tools, I don't know, like ours, that run very, very quickly, and they're not in their way, right? It fits in their tooling, you know, UIs and IDEs and experiences that say, like, this is the most important thing for you to fix. You can kind of ignore the rest. We'll get to it later. Pay attention here, and then get out of their way. So you got to enable them and get them started on the right things, and then just be a partner. We're seeing it a lot, honestly, that AppSec teams know that in order to scale, they have to have friends in software engineering, and they have to be able to automate a lot of these things. So it's coming. I'm not perfect. I don't have all of the answers, but give them tools they can use, and give them tools that are easy, and empower them and trust them, and you'll build a good relationship.
We did some survey in our cloud application security survey last year, and you know, a huge proportion of developers filling out that survey were clearly deeply cared about security. So, you know, I think some of these old kind of thought patterns of, oh, developers are this way and security folks are that way, you know, are probably not holding as true these days as maybe they were, you know, a decade ago or so.
I agree.
Okay. So have we dealt with all these questions?
There was one more, if you just want to answer this one quickly, Joni. So Yano asks, are there any specific tools that you would recommend to get started with this test-driven security? You can probably think of one, right?
Thanks for the alley-oop. Yeah.
This is a stack of plant question.
No, I know. I'm like, Bruno, I don't know who you are, but thank you very much. Yes, I highly recommend you check out StackHawk. So what I love about our product is it's language agnostic. So you can, no matter sort of what your application is built in, you can run tests against it. And it also focuses on the API layer, which is super important for modern apps. That's where all the goodies live, is in that communication layer between backend and front end. And you can get started for free. We even have a free product. So if you want to just start playing around and getting to know different technologies, I encourage you to try that out. And then we have great friends at Sneak that have built also great products and have free versions that you can start testing with that also integrate with ours. And so those are really great places to start. And then the other companies have really good tools also. So that last slide, I don't know if you'll be making these slides available, but it has a list of companies and technologies that I think are pretty developer first that folks can check out.
Great. Thank you very much, Joni. That was a great talk. I know we really enjoyed it. So we'll let you go at this point.
Thank you so much. Have a great day, everybody.
You too.